everyone. In my last videos, you have seen what is machine learning, what is artificial neural network, what are the different applications of artificial neural network. And in the neural network, you have seen a single layer perceptron and a multi-layer perceptron. So as you know, the single layer perceptron only has an input and output layer, and but a multi-layer perceptron has a single or multiple level of hidden layers in between it. So we are now in this video going to learn about the multi-layer perceptron classification technique using the scikit-learn library on a dataset called wine dataset. And this wine dataset is given by the UCI machine learning repository. It has various chemical features of different wines. And these wines are all grown in the same region of Italy, but the data is labeled by three different possible cultivars. Now we will try to build a model that will classify the what cultivar a wine belongs to based on the chemical features of the neural networks. So let's first try to get the data from the wine dataset. To do that, we are going to import the pandas as PD and then use the pd.read CSV, and this will read the name of the wine dataset file with all the columns present in it. So these are the various attributes or features of the wine dataset. So once you run it, the whole dataset will be imported. Now, to get a detailed idea about the dataset, I have added this link. So you may open it to see the dataset characteristics, what are the attributes, instances, sources, and other various information and relevant papers about it. Now, let's see. You don't know the whole structure of the wine dataset. Let's try to pull out some information about it. What are the features and what are the values of it? So to do that, I'm going to use the head function using the wine variable, which has all the data from wine dataset, and that will give us um, 5 rows with all the columns or features that are available. Okay, so it's kind of a flattened picture to have a better picture of it. Now I'm going to change the structure of the wine dataset to this type. Describe function dot transpose will transpose the rows and column of the head. Now we will have in this way. So the transpose, what it will do, it will describe the whole dataset, wine dataset, in a different view where you will have all the features and the count, mean, standard deviation, minimum, and various percentages and maximum of the dataset values. So now you can see what is the structure of the wine dataset. Let's see how many number of data points, that is rows and number of columns available. So let's see that. To get that detail, we need to use the wine dot shape. So what it will do, it will give us 178 set of rows or 178 data points available with 14, that is 13 features and one label column. That label column is actually our cultivator column. So let's do one thing. Let's set up our data and our labels. So to do that, we need to drop the cultivator column. So we just need to set up our data with only 13 important features. So we are going to delete or drop this cultivator. So this first row will be dropped from the dataset. Now, after dropping it, assign it to the X variable. So this is setting up the data with only 13 features, ignoring the cultivator one, and wine cultivator only, that column will be assigned to the Y. So we are setting up the label or target with only our cultivator column. So here X doesn't have cultivator, but Y only have the cultivator column data. That is our label. Now, as we have the whole structure of our data set, now let's split our data. So how to split our data? To split it using the X training testing and Y training testing. So use the trend test split function on the X and Y. So before that, you need to import the trend test split from the scikit-learn model selection library. So after you are done with this, next process, next step is our data pre-processing. So what happens here? We are going to import the standard scalar from scikit-learn pre-processing library, and the standard scalar function will be called, and whatever output will be applied will be assigned to scalar. So neural network in Python, it may face some sort of problem while converging before the maximum number of iterations allowed if the data is not normalized. So actually, for number of feature scaling in our model, the multi-layer perceptron is sensitive to it. So it's mostly advisable to always scale your data. So for that, for scaling purpose, we are using standard scalar. And we make sure you need to apply the same scaling to the test set for the meaningful results. Okay, and there are a lot of different methods for normalizing the data, but we are going to just use the standard scalar for it. So for having more detail about the standard scalar, try to follow this link, and it has all the documentation regarding our standard scalar scikit-learn pre-processing. Now apply the fit function on the training data, and then the standard scalar will be applied with all these arguments. And to apply the transformation to data, we are going to call the transform function on the scalar x training and x test, and now apply those or assign them to the x train and x test variables. So we did the scaling. The next thing is to train our model. So for training our model, let's import the MLP, that is the multi-layer perceptron classifier model, MLP classifier, from the neural network scikit-learn. Okay, and this function MLP layer, hidden layer sizes max iteration, what it will do, an instance of the model will be created, that is MLP, where the number of parameters can be chosen, but the emphasis is always on the hidden layer sizes. So for parameter, we pass a tuple consisting of number of neurons we want at each layer. Okay, and here we have chosen 3 layers with same number of neurons, that is 13, 13, 13 number of neurons as their features, 13 in our data set. Okay, and it is assumed that there are maximum 500 number of iterations to be present. So there are 3 hidden layer sizes with each hidden layer consisting of 13 features or 13 neurons. So got an idea? Now after we have our MLP, now let's fit the model using the X train and the Y train. So we are fitting the training data to the model. So after running this whole portion of this code, it will give us the MLP classifier with the layers and the number of neurons with the maximum iteration set up already. So next thing is about prediction and evaluation. So this is where we are going to predict our data. So here our output will show the default value of other parameters in the model. So while predicting, we will use the MLP and predict function on the X test data. Always use the test data for the prediction. Now let's see a confusion matrix and the classification report. That will give us a clear picture of our data set. So we will use the scikit-learn built-in metrics, classification report and confusion matrix to evaluate our data, and also to understand how our model is performing. So apply the confusion matrix on the Y test data and the predictions from here. And this is giving us our confusion matrix, and the classification report can be also found out using the same parameters. So as you see here, everything is classified clearly, and as you see here, 19, 18, 8, all the three labels has been classified correctly, and we don't have any misclassified result, and we don't find any misclassification, as you see. But there is a disadvantage of using MLP model, okay, to interpret the model itself, to understand the model itself. And the weights, the biases that you remember we have seen in the PowerPoint presentation of the multilayer perceptron, they won't be easily understandable or interpretable in relation to the features that are important to the model itself. So for extracting the weights and biases of the MLP after training our model, we should extract the coefficients and the intercepts. Okay, so those are important. So what are the coefficients? COEFS underscore. This is the list of weight matrices where the weight matrix at index I represents the weight between layer I and your layer 1. Here I have provided the detail. Okay, and the intercept is your list of bias vectors where vector at index I represents the bias value added to layer I plus 1. So first, if you want to find out the length of the coefficients, it will give you 4. Okay, and then let's say you want to iterate over all the coefficients, then for each layer it will give you the weight matrix for each layer. Okay, so first input layer 13, 13, 13 input, 13 output, and then 13, 13, then 13, 13, but here 13 and 3 because 3 is for 3 outputs. Okay, so the last layer have the weight matrix 13 and 3 as output data because of the number of cultivars. So as I have already explained you in the beginning, that we are making trace on the possible cultivars of our wine data set. That is why it is giving us 3, because we need 3 specific labels or features. So to first find out the length of initial layer, it will give you 13. For the intercept also, it will give you 13. So now you got an idea that how many hidden layers are there and how output you are getting, and what is our classification report and how are we classifying the data set. So this is an example of multi-layer perceptron on a data set. So what you can do, you can change the number of hidden layers. So as we did here, yeah, so number of hidden layers and the iteration also, change them and see how they affect the result of your network model. How does it predict it in the confusion matrix and the classification report? See what changes are you observing.